So let's do some questions. So the first question is that there is a block of mass 2 kg and it is placed on a long frictionless table. It is pulled by a horizontal force which is constant, that is, it is not changing, the value of the force is not changing, and it is found that if we want to move the object by 10 meter in first 2 seconds, if we need to apply some force. So what is the magnitude of that force that we need to apply? So the first question, so let's write the given things. Mass is 2 kg, the displacement is 10 meters, initial velocity is 0, and we need to find the force that we need to apply. So acceleration, first we need to find the acceleration. Okay, force is F equal to ma, so we need to find acceleration. We know mass. Okay, so for finding acceleration we can use this formula, S equal to ut plus half at square. So here S is 10, u is 0, so this will become 0, plus half a, and time, so time is 2 seconds. Time is 2 seconds. So let me solve this. So what we will get, 10 equal to half into 4a. So this will be 10 equal to 2a. So a will be equal to 5 meter per second square. So a is 5 meter per second square. Now what will be the force? F will be equal to ma. So that is mass is 2 kg into acceleration is 5. So this means 10 Newton. So this will be our answer. So we only needed to find the acceleration. So acceleration was easily calculated using this formula. Again, remember, this equation is valid when the acceleration is uniform. Okay, otherwise this equation is not valid. Now in the second question, we again have a car which is moving at 40 kilometers per hour and we have to stop the car. Okay, in the next 4 meters. So in when the car can travel up to 4 meters before stopping, and the weight of the car is also given, mass of the car is also given 2000 kg. So we need to find the force that we need to apply in order to stop the car. So again, let's try to write what are the things that are given. So initial velocity is 40 kilometers per hour, and obviously we want to stop this, so the final velocity will be 0. One more thing, let's convert this into the SI unit. So 40 kilometer per hour can be converted into meter per second by this formula, 5 by 18, that is 1000 by 3600. So once you solve this, you will obtain that this value is equal to 11.11 meter per second, and final velocity is 0 meter per second. Apart from that, mass is 2000 kg, 2000 kg, and the displacement is 4 meters. So we need to find the acceleration. Ultimately we need to find the force, but to find the force we need to find acceleration. So acceleration can be found out using this equation, v square minus u square equal to 2as, because we have v, we have u, we have s. So s equal to, sorry, the acceleration is to be found out. So a equal to v square minus u square upon 2s. So by this, acceleration will be equal to 0 square minus 11.11 whole square upon 2 into the displacement is 4, so 2 into 4. So after solving this, it will be 123.43 divided by 8. So this will give you acceleration equal to minus 15.42 meter per second square. Now what does this sign indicate, minus sign indicate? So this minus sign indicates that it is deceleration. Okay, deceleration. So what does this mean? That the velocity is decreasing, the magnitude of the velocity is decreasing. So ultimately the force will be equal to, F will be equal to ma. Mass is 2000, a is 15.42, equal to 30840. So approximately force will be equal to 3.08 into 10 to the power 4 newtons. Now obviously the minus sign can also be put up here. but we are already calling it the braking force, so obviously braking force will slow down the velocity, so therefore we need not write minus here, but obviously minus sign indicates that the force is stopping the object, force is deaccelerating the object. In the third question, we have a TV picture tube in which the electrons are ejected from cathode, and the velocity of the electrons initially is quite negligible, but they can reach up to 5 into 10 to the power 6 meter per second, only in 1 centimeter of the distance they travel. So if the motion is straight line motion, so we need to find the force that is exerted on the electron, and mass of the electron is also given. So let's write the given quantities. So the initial velocity is 0. They have given that the initial velocity is negligible, so we can consider approximately equal to 0. Final velocity is 5 into 10 to the power 6 meter per second. The displacement in which it achieves this velocity is 1 centimeter, or 1 into 10 to the power minus 2 meters. So acceleration will be v square minus u square upon 2as, which will give you 5 into 10 to the power 6 whole square minus 0 square upon 2 into 1 into 10 to the power minus 2. Sorry, there will not be a here, only s. So it will be equal to 25 into 10 to the power 12 upon 2 into 10 to the power minus 2. So this will give us acceleration equal to 12.5 into 10 to the power 14 meter per second square. So what will be the force? F equal to ma. 9.1 is the mass into 10 to the power minus 31. This is in kg. Acceleration is 12.5 into 10 to the power 14. So we get approximately 1.1 into 10 to the power minus 15 newtons. This is approximate value of the force that is applied on the electron. So in this question, the force that is applied on the electron is this much, which helps the electron in gaining this much velocity. Now question number 5, we have two blocks of equal masses. No, before that we have question number 4 as well. So a block is there of 0.2 kg and it is suspended from the ceiling by a light string. Now we suspend another block of mass 0.3 kg from the first block. Now we need to find the tension in the two strings. So we have two strings, we need to find the tension in both of them. So the fourth question. So let's try to draw the diagram first. So the situation is something like we have a ceiling. From this ceiling we have two blocks. One block is of 0.2 kg and another block is of 0.3 kg. So 0.2 kg, then 0.3 kg block. Okay, so this is the situation. Now let's isolate the system. First we will discuss about 0.2 and then we will discuss about 0.3 kg object. So on 0.3 kg object and on 0.2 kg object, let's try to find the different forces. So one force is the downward force, which is the weight, which is mg. So mg will be 0.3 g. Then again there will be a force downward for this object as well. So it will be mg equal to 0.2 into g. Now there will be an upward force for both of them. So the upward force will be the tension force for it, and for this object we will understand what will be this force. Wait for a moment. So for 0.2 kg object, this is the situation. So let's first try to solve this part. Okay, so here t minus 0.3 g equal to 0 because this is at rest, so f net is 0 for this situation. So tension comes out to be 0.3 into g, 0.3 into g. Oh sorry, this tension. Okay, not this one, this tension, and let's call this one T1. So T will be 0.3 G. Now G is approximately 10, so 0.3 into 10, so it will give us 3 Newton. So the tension on this object upward will be 3 Newton. Now this 3 Newton will be there, so T1 minus 0.2 G plus T equal to 0. Again, understand what is happening. So the tension is also there. Okay, what is happening is that the tension for this one will be like this, and for this one will be like this. There, okay, tension is in the opposite direction from the object. So the string is this one, so same tension will be applied on this, which will try to move it down, and same tension will be on it, which will try to move it up. Okay, so T is in the downward direction for 0.2 object, so T1 minus 0.2 plus T equal to 0. So from here T1 equal to 0.2 G plus T, which will be 0.2 into 10 plus 3, so it will give us 5 Newton. So T1 is approximately equal to 5 Newton. So T1 is this and T is 3 Newton. So these are the tensions in the two strings. So what we need to do is first find the tension in the below object, first find the forces in the below one object, and after you solve that, then move on to the upper object. Now in the fifth question we have two blocks. They are of equal mass m and they are tied to each other through a light string. So string is used for attaching them. Now one of the block is pulled by a force F. Then we need to find the tension in the string joining the blocks. So the string which is joining the block, it will experience some tension. So let's try to imagine this. So this is fifth. Okay. So what do we have here? So let's say this is a surface. Now we have two blocks B and let's say block A, and they are attached by a string. Now let's say we apply a force F on A. So there will be some displacement in this direction and there will be a tension in this string. So let's isolate the bodies. Okay, so this is body B and this is body A. So the forces on it are, on body A, one force F is there, and obviously tension will be like this. A normal force is this side, this is weight mg, same weight mg, here tension will be there, and this side there can be a resultant force ma and normal force. So ultimately what do we have? We have T plus ma minus F equal to 0. So from here F is equal to T plus ma, F is equal to T plus T. How? Because from here T minus ma equal to 0, so T is equal to ma. Okay, from this equation T is equal to ma. So ultimately we get this. So F is equal to 2T, or tension is equal to F by 2. So this will be our tension. So let me again repeat. So this is the scenario. This is for B, this is for A. From here we can find that tension is equal to ma. Now from here T is equal to, there is another force ma. So T plus ma minus F. So F is equal to T plus ma, and then ma is equal to T. So at the place of ma we can put T. So this is what we get. Now in the sixth question, we have a particle whose mass is 50 gram. It is traveling in a straight line. So the graph is given, velocity time graph is given. So we have to find the force on the object at t equal to 2 seconds, 4 seconds and 6 seconds. So let's first try to draw the graph. So what we have is that on y-axis we have velocity, on x-axis we have time. This is in meter per second, this is in second. So the graph looks like here 5, 10, 15. So graph looks like something approximately like this. It goes till 15 actually. Then nothing till 4. Then it moves down. So this angle is, let's say, theta. This is D. This is, let's say, E. And let's say this point is C, this point A and this point B. Now the angle, these two lines are same, so this angle is also theta, so this will be 180 minus theta. So this much is given. Remember this is 8 here, okay. So now let's solve this question. So first of all, what are the given things? So mass is 50 gram or 5 into 10 to the power minus 2 kg. Now this slope OA is tan theta is equal to perpendicular upon base 15 by 3, that is 5 meter per second square. The slope is the acceleration. So at t equal to 2 seconds, acceleration is 5 meter per second square. So F is equal to ma, 5 into 10 to the power minus 2 into 5.25 Newton. So this will be the force. So what we have done is that we have used the slope in order to find the acceleration, because this slope, this angle gives us the acceleration, okay, because acceleration is velocity upon time, and we know that the slope tan theta is equal to y upon x, okay, perpendicular upon base. So y upon x. So therefore we have done this. So by finding the acceleration we have found out the force. Now this was for 2 seconds. Now at t equal to 4 seconds, the force will be 0 because the acceleration is 0. So acceleration is 0 here, therefore the force will be 0 Newton. So if you look closely, look here, the acceleration is 0 because velocity is constant, so the force is 0 in this region. And at t equal to 6 seconds, the acceleration is the slope of BC, so that is tan theta B by EC, which will be 15 by 3, which will be 5. But it is negative, okay, important thing is that it is negative, so the acceleration will be minus 5 per second square because it is decreasing, okay. So ultimately force here will be 5 into 10 to the power minus 2 into minus 5, that is minus 0.25 Newton. So these are the various situations in which we have different forces. So this is This minus indicates that the force is opposite to motion. Force is opposite to motion, and this plus sign indicates that force is in the direction of motion. In the seventh question, we have two blocks A and B having different masses, and they are placed on a frictionless table. Now the block A is pushed and it is behind block B, so they will accelerate. So now if block A is exerted has been exerted a force on it, and this block will obviously exert force on B because they are in contact. So what is the force exerted by experimenter on A? So to understand this, let's draw the free body diagram. So this is answer solution 7th. So this is our surface. Now let's say we have two objects M1, M2. Now we apply some force on it, so there will be some displacement. So let's say this is A, this is B. So on object A we have MA into G, weight downward. Obviously there will be a reaction force upward. Then the force is applied in this direction, this force. There will be some acceleration also. Now object B, so MB into G, reaction force, normal force, it will be different. Then F is there because we are applying some force, and MBA is there. Let us use different letters for this forces. So this, let's say this F is the contact force. Actually this F should be like this. This is the contact force. This should be like this. F is the contact force between A and B. And let's say this applied force is a small f. Force exerted by experimenter on A. So we should again, so this is force like this. This B will apply force like this on the object A, and we are applying some force F. Okay, and here also there will be a force, contact force in this direction. Okay, so the net force F net will be equal to F minus, or we should write, we have two forces, F minus F equal to net force MA into A. And here again we can avoid writing it here. So here the net force is obviously MBA, only this force is the net force. So F is equal to this is F minus F equal to MA G, or MA actually. So F will be equal to F minus MA A. So this is another equation. So we can equate these two things. So what we will get, F minus FMAA equal to MBA. Now F will be equal to MAA plus MBA. A will be common, MA plus MB. So ultimately F will be F upon mb plus ma, because from here we can obtain A to be F upon mb. So now F1 plus ma upon mb. So this will be the force exerted by the experimenter. Experimenter is applying this much force. So let's again quickly summarize what we have done. So on object A, this is the force applied by experimenter and this is the contact force by B. And on object B, this is the contact force applied by object A. So here the only force is F. So F will be equal to MBA, that is the net force. And here there are two forces, F minus F. Okay, so it will give you the net force MAA. This is the net force. Remember, when we have motion, then net force is not 0, it will be MA. So because of that we are using MA. Now after that, using these two equations, we have found that small f is equal to this much. Now question number 8. So we have a raindrop of radius 1 mm and mass 4 mg, and they are falling with speed 30 meter per second. So they splash on the head and then they come to rest. So we will assume that the drops cover equal distance and their radius are almost same. So we need to find the force exerted by each drop on the head. So let's try to solve question number 8. So radius is 1 mm or 10 to the power minus 3 meter. Mass is 4 milligram. So that is 4 into 10 to the power minus 6 kg. Displacement is 10 to the power minus 3 meter. Final velocity is 0. Initial velocity is 30 meter per second. So first let's try to find the acceleration by this formula. So we will have 0 square minus 30 square upon 2 into 10 to the power minus 3. So acceleration will be minus 4.5 into 10 to the power 5 meter per second square. Again minus indicates deceleration. So ultimately force will be, mass is 4 into 10 to the power minus 6 and acceleration is 4.5 into 10 to the power 5. So it will give us 1.8 Newton. So the force exerted is 1.8 Newton.